be a heterotherm. Okay. Now let's think of some of the exceptions. Why is it that we zoologists are not that fond of cold-blooded and warm-blooded? So I think, actually, let me go back for a second. What of these terms would you say are typically associated with being cold-blooded? So when people talk about cold-blooded, would it be more an ectotherm or an endotherm? And I hope you're thinking ectotherm. And then when you think about a cold-blooded animal, again like that bullfrog, are they a heterotherm or a homeotherm? And I hope you're thinking a heterotherm. Okay, so humans are more endothermic homeotherms. A bullfrog would be more an ectothermic heterotherm. And now that brings us to the exceptions. So we get something here that's really kind of interesting. If we take a look at the hummingbird situation, and hummingbirds will be returning to our area very, very shortly. In fact, about the time that you take your lecture exam 3. You want to check that schedule that I sent out yesterday, of the 24th of March, and take a look at all those dates when we have our online live quizzes or exams. So I'm counting on everybody to follow that. Well, if you take a look at a hummingbird that, again, probably returning here to our area, Illinois anyway, about the 15th of April. On the left side of this diagram, you see a hummingbird that's just eating and feeding fine during the course of a day. And with all that food, that's plenty of energy. The hummingbird's very active, and it has no trouble having a high, steady body temperature generated by its own heat. So if it's a high, steady body temperature generated by its own heat, what are the two terms that we would associate with the left side of this diagram for this hummingbird? And I hope you said a homeothermic endotherm. But now take a look at the right side. If, at the bottom, it says if nectar is adequate, then during the evening, the hummingbird, while it's resting, may maintain its high body temperature. Here, we see it in Celsius, 39, so that's even higher than our core body temperature, which is about 37. But if you see that if nectar is scarce, and that could be the case when these hummingbirds first come back, my goodness, they've migrated perhaps over 1,000 miles of this little bird flying to get back to Illinois. That's why I like to have my hummingbird feeders out right away in April. In any case, if they get back and there are not a lot of flowers for them to feed on, then in fact, the top conditions, top right, are probably what's going on. Nectar is scarce, there's torpor, and the body temperature is going to drop at night. So it raises the question. Overall, throughout the course of a year, if you think about a hummingbird, what's the term that best applies? Well, they're endotherms, but are they homeotherms? Well, on the bottom, with plenty of nectar, yes, they're homeothermic endotherms like a mammal. But up at the top, you see the capacity for a homeothermic endotherm to actually sometimes be a homeothermic, an endotherm that is a heterotherm that allows its body temperature to vary even though it's an endotherm because it produces its internal body heat. So I'm going to clarify that. At the top right, instead of being a homeothermic endotherm, it's a heterothermic endotherm. Okay. And so the answer, what term applies to a hummingbird that goes into torpor, what terms apply, and it's an endotherm still, but it's a heterotherm. So go back a slide just to review what those terms were. When a hummingbird lets its body temperature drop, it's still an endotherm, but it technically is a heterotherm. Okay, now going ahead. Here's another situation. Fish normally do not control their body temperature by generating enough heat to maintain a steady body temperature. Most fish, whether in the ocean or in freshwater systems, maintain the temperature of their environment. So if the water's cold, they're cold. So if they're getting their heat from outside the body, are they ectotherms or endotherms? Well, they're ectotherms because they're getting their heat from outside the body. But lots of bodies of water maintain their temperature. They don't change quickly. I don't know if you've thought about that. But if you go to the ocean, let's say, and you have a chance to swim in an ocean or a chance to swim in a lake, and you go in and you have a fun time, I hope the water's not too cold, and then you come back the next day, is the water radically different temperature? And the answer is no. It has to do with something called thermal inertia. And with thermal inertia, the tremendous mass of large bodies of water, could be freshwater, of course it's the oceans, these systems cannot change their temperatures quickly. It would require an incredible input of heat. And therefore, oceans and large lakes, like the Great Lakes, tend to maintain a steady temperature. Over the course of a year, yeah, they might fluctuate a few degrees. Maybe even more if it's a Great Lake like Lake Superior. Might change, who knows, Fahrenheit, maybe 10 or 15 degrees Fahrenheit. But if we think about tropical marine systems like we're looking at, this is a temperature that's not going to change much. So this is another exception. Are they endotherms or ectotherms in this tropical marine ocean environment? Well, they're ectotherms. But does the body temperature fluctuate a lot? No. So they're ectotherms and they're homeotherms. So ectothermic homeotherms. And that now brings us, one of the reasons I really wanted to narrate this for you, to a very unusual case. We're going to spend a lot more time as we go through this course, mostly for the next lecture exam, and I'm going to talk to you about the importance of size. We won't spend a lot of time right here going through it. So I just want to tell you the principle, and then we'll help you to understand the principle later. As an organism gets bigger, and here we see a human compared to one of the giant sauropod dinosaurs. They have one of these, by the way, mounted at the Field Museum in Chicago. Not a good time now to go there, but maybe you can see pictures of it if you go online. As any organism gets bigger, of course its volume, its mass is increasing. That's what we mean by bigger. But the surface area of the skin, all the skin, even the bottoms of the feet, everything, that surface area is also going to get bigger. Okay, so bigger people need bigger sweaters. Okay, but it doesn't increase as fast as the volume. The surface area does not increase as fast as the volume. So this is a much bigger critter, and it has proportionately less surface area. If you think about this then applied to dinosaurs or anything big, if they're an ectotherm, they're going to gain or lose heat through their surface. You do this. A lot of your heat in the summertime is lost through your skin. You also lose a lot through your breath. I don't know if you ever thought about it. You breathe in cold air, you breathe out warm air, so you're losing body heat. But in the summertime, we don't lose so much body heat because the air is already pretty warm. So we tend to lose heat in the summertime through our skin. Well, dinosaurs, if they got too hot or too cold, or if there's some temperature and now the environment, the air temperature drops, for example, in the evening, they would then cool off through their skin. So let's imagine this giant sauropod in front of us at noon or in the afternoon, and it's a sunny day, and the animal's really getting heated up by the sun. And now the air temperature drops pretty fast at night, maybe even 20 degrees Fahrenheit it drops at night. How quickly will this dinosaur cool down? And the answer is that when we think of the largest land animals like these sauropods, they're so big that they cannot cool down much during the evenings when the temperature cools. And they can't heat up too much in the afternoon when they've got sunshine. And so the point of gigantothermy is that when you're a giant, and that's what the giganto is referring to, you can't considerably heat up or cool off in the course of a day. So what they are, the giant sauropod animals, is they're ectotherms, but they have a steady body temperature. And so what term are we talking about for steady body temperature? And I hope you're thinking homeotherm. So gigantothermy is that when we have the largest terrestrial animals, they will not heat up or cool off considerably in the course of the day. They're just too big. They don't have enough surface area. Now today, the largest of all the animals on Earth is a blue whale. Now, blue whales make their own heat, and they also live in an environment with pretty steady temperature, although when they dive really, really deep, they encounter cooler water. In that particular case, they don't have that much surface area either, and so for them, being so big, they can't cool off, if they're really, really active, too easily. And so it turns out that in some marine mammals, which is what a blue whale is, these animals have to have special adaptations to cool off. A very active dolphin, dolphins aren't that big, but a very active dolphin has special adaptations to actually get rid of heat, special ways to get rid of heat.